Okay, this lecture is over the ICMP protocol. ICMP stands for Internet Control Message Protocol, and the purpose of ICMP is primarily to communicate problems with data transmission, like time to exceed, which means the time to live went to 0, or to refer back to destination unreachable type issues. It can also be used as a diagnostics tool, which we'll see in the next thing here, which is tools that you should already be aware of that use ICMP. And you should have covered this in CIT 161 or whatever networking class you had. You may even learn about this in A+ class, etc. So the first one is ping, and ping is a tool to verify that a path to a host is working and that the host is up. So what you do is you ping a host, and an ICMP request packet is sent to that host. So if it successfully travels through the network, makes it to the host is supposed to respond with an ICMP reply, and that will make it all the way back, hopefully, to the machine that initiated the ping. And if it does, you know the route's up, you know the host is up, and you also get some timing statistics about communications from your machine you're on to the host you're pinging. The other tool that is very handy is the traceroute tool. And this is kind of a cool trick, if you will, that is done with ICMP or ping type packets. So what happens is you send an ICMP request just like you would with a ping. However, you set the time to live to 1. So what happens is that time to live is decremented every time we pass through a router. So let's say you're pinging google.com from your home. So it'll send the packet on its way to Google. It will go to your router in your home. The router will decrement the time to live by 1, so it will go to 0, and therefore the packet will be returned. So you'll get a return packet from your router. You can learn its IP address and some other information about it. The traceroute command then sends a ping packet destined for Google with a time to live of 2. So it'll go through your router. That time to live will be decremented from 2 to 1. It will then go to the next router, which is probably a router at your ISP. It will decrement the time to live. The time to live will go to 0. That packet will be returned to you. So now you know information about the router that comes after your home router, the next hop from there. And it does that until the packet makes it all the way to its destination and comes back to you. So like I said, very, very handy tool. This is what an ICMP packet looks like. It'll be anywhere from 16 bytes in length to 584. So this has the breakdown of what the fields are and how large they are. In a little more detail, we have a type field that specifies what type of ICMP message this is. So for example, I kept saying echo request or ICMP request, same thing. That's a type of 8. When the specification or the protocol was developed, there were 43 non-reserved types. A number of these have since been deprecated, and what we mean by deprecated, if you're not familiar with that term, is we had something, it was part of the protocol, and we either no longer use it or we have replaced it, and then at some point in time it will be declared deprecated, which means you're not supposed to use it anymore. Within each of these types, we can have what's called a code. I like to think of this as an ICMP subtype. This code is going to be specific to the type of ICMP packet we have. A lot of these don't really need a subtype, so they're forced to be set to 0. But then there's others, for example, a destination unreachable type has 0 through 15 as possible subtypes. And I think that's one of the ones that has the most subtypes. But we'll look at that here in a moment. You then have a 2-byte checksum, which, like all checksums we talk about in here, are for error checking the packet. And then we have something 4 bytes called rest of header. The contents that are in here will vary based on type and code. And then finally we have a data field, which is 0 to 576 bytes. Again, its contents are going to vary based upon what the type and code is. And a lot, if not the majority, of ICMP packets will have no data associated with them. So I like to look at real-world examples. So here's a frame from Wireshark, and you see that we have the whole frame here. This time I'll probably look at the Ethernet layer, and then we'll go straight to the ICMP. In the future, I will probably stop this kind of intermediate discussion, but again, just to reinforce our Ethernet frame, there's a destination MAC address, there's the source MAC address, and then here's the enclosed packet type, which is 800 for IP. So ICMP is a type of IP packet, is what I really wanted to point out by looking at that. Now, if we go down to the bottom where we actually have the ICMP message, notice that I've clicked ICMP in the left side, and notice what is highlighted in the right side, which is the actual ICMP message. So just kind of going through and pointing this out, this is decoded on the left, but you see that the type is an 8, which is an echo request, and notice over in the left they say echo or ping request, because ping is the most common thing you do with that. So they're trying to use terminology you would be familiar with. Next we have a code, and like I said, a lot of times this code is 0. So for a type 8 echo request message, this is always going to be 0. Here's our checksum to make sure that everything's intact. And then the rest of the header is shown. And for type 8, this is an ID number and a sequence number so that we can match up replies that are coming back to the process that generated the request. And notice I have everything highlighted there for the ICMP packet. So this is an example of where there's going to be no data. We don't need the data. Everything we need is in the message itself. So that finishes up the discussion of ICMP.